Today we're going to be running our paralytic shellfish poisoning ELISA. When you order a kit, this is what it comes with. The first thing you should do is make sure you read the instructions really well and thoroughly. Our antibody in our kit detects neosaxitoxin and saxitoxin equivalently. So it has a broad spectrum there, and with a simple L-cysteine conversion step in sample prep, you can detect all the different, or a lot of the different gonyaytoxins that are associated with paralytic shellfish poisoning. So that's what's kind of unique about our kit, and we're going to run that today and show you how to do it. So read the instructions thoroughly. When you order a kit, what comes in it it'll look like this. We have wash buffer and diluent. This is a 5X, this is a 10X. You'll need to dilute those first for washing your plate and for diluting your samples. You'll have TMB, which develops the ELISA, and stop, which stops it at the end so that you can read it on a plate reader. And in the smaller box, we have our primary antibody here. This is the one that detects both neosaxitoxin and saxitoxin. And we have our HRP conjugate, which allows for the detection of the toxin in your sample in the ELISA, and a set of standard curves. You'll also have a plate in a dry pack. When you open it up, it's a strip well plate, so it has 96. This is just half a plate. But these can pop out as you need, so you don't have to run the whole plate at once. You can run half a plate, as I've done before here, or a third of a plate. There's enough standard to be able to do that. All right, what you'll have to provide are a set of pipettes and tips and vortexer to mix samples, and a plate reader capable of 450 nanometers. All right, so let's get started.
Add 50 microliters of your standards and your samples to the wells of the plate. The first thing I always do is to set up a plate map, which is a written plan of what sample goes where in the plate. And you can see that to the right. And it just keeps me organized when plating, and it helps me come data analysis time to remember what went where. And I use the sticky note just to keep me on track so that I don't add anything to the wrong well or column, like adding twice or missing a well. So just a tip as you're going through this. For the standards, I add them in duplicate, and I start with the 0 or ethanol only, which is your negative control, and then I move from the lowest to the highest concentration. It's important that you mix your standards each time before plating. And after I've loaded the standards in the first two columns, I move the sticky note over and start adding the samples of the unknown concentration, the ones that I want to test with the ELISA, also in duplicate, according to the plate map. After all the standards and the samples have been loaded, I add 50 microliters of the Saxitoxin antibody. First, I vortex it to MIC to be able to load it with a multi-channel. Another tip here is when you add the tips to a multi-channel, you kind of smack them down onto the tip box just to make sure they seat well. And then, as you see here, I'm hand tightening the tips because I want to make sure that there's a good seal, that none of the tips fall out, and that I'm pipetting the exact amount to each well. So here I add them to all of the wells of the plate, and now we incubate for 30 minutes. Next, we add the Saxitoxin HRP conjugate. This comes in an amber vial to protect it from the light. So I'll remove the plate from the plate shaker, and I set it here on my working desktop. And I'm going to add 50 microliters to each column with the multi-channel pipette again. Because this is light sensitive, when I add this back to the plate shaker, I will cover it just to protect the Saxitoxin HRP and all of the reactions from the light. and we incubate for another 30 minutes. The reactions have now been mixing for an hour, and so now we need to wash the plate. First, shake the plate firmly with a downward motion to dump out all of the wells over a sink. I then tap it firmly 2 to 3 times on a paper towel to make sure all the liquid is out. Then I add 250 microliters of wash buffer, dump the plate out again in the sink, tap it, and repeat for a total of 3 washes. For the last tap, you'll see me hit it several times on that paper towel just because I want to make sure I get all of the liquid out of the wells prior to developing it. Now we're going to add the substrate, or TMB, to all of the wells. The HRP in our conjugate will act on the substrate to turn it blue. So I'm going to add 100 microliters of TMB to all the wells. And I add this very regularly, kind of methodically, to get through the plate, because I want to add it and stop it with the same regularity. Since this is there's a time component to this. I add 100 microliters of TMB and then wait for the color to develop. I put my plate on a white background because it makes it easier to see the blue color, and it'll take 5 to 20 minutes depending on what your samples look like. You're going to want to stop the reactions once you see a high to low color development in the standard curve, and your unknown concentration samples are all within that range. That's really important. The first plate I'm showing you here, the samples are all coming up blue, but the standard curve isn't really dark yet. But we want to stop it so that our samples are still in the linear range of the standard curve and therefore quantifiable. In the second plate here, you can see where the standard curve has developed a bit more or for a bit longer, but the samples aren't really blue yet. That plate needs to wait just a bit longer. So in total, again, the plate can be stopped anywhere from 5 to 20 minutes. When you stop it doesn't really matter. What matters is how long it takes for your unknown samples to develop in color that is within the range of the color development of the standard curve, so that the 0 is really, really blue and the highest concentration is clear or very, very light, and all of your samples are in between that. When your samples and standards are ready, you'll stop the reaction with acid. Since color development deepens over time, we need to denature the enzyme to prevent the color from continuing after our optimal blue, after we've got our samples within that standard range. And we do that by adding acid. And now you can see how the plate has gone from blue to yellow, and my samples have all come up and are within the range of the standard curve, or those first 2 columns. This can be a little hard to see with your eye, but the plate reader does measure this difference in optical density much better.